Welcome to the SmartSkeMa video. In this video, we introduce our use cases in Kenya and we will give a live demonstration of the SmartSkeMa web interface. Now I will show you a series of use cases. Use case 1 to 3 show how SmartSkeMa is used in Kenya. To develop the use cases, we work together with various organizations such as Namati, Cadastre.org, Spatial Collective, Kenya National Land Commission, Kajiado County Surveyor Offices, and the Kajiado County Land Registration Office. This is the first use case which illustrates how to add data to SmartSkeMa. In this case, our users are tool operators. For example, people from land registration offices or land use planners, or people from non-governmental agencies involved in community mapping. The tool operators want to extract and geolocate the geometries of sketched features from sketch maps and annotate these sketched features with land-right attributes. On the left side here, we have information about Kajiado from official maps, enhanced with data from the UAV images. Furthermore, we have sketch maps. In this case, members of the Kajiado South Central community have jointly drawn sketch maps of natural features, the community lands boundary, the bomas. Bomas are the homesteads families live in, and they also included the olopololis, which are the fenced grazing areas associated with the boma, and they documented the associated land tenure attributes. In this picture of this use case, you can see the sketch map, which is here, the map where we already detected the spatial features in the sketch map and qualified them. And in the live demo, which I show you now in a second, we will see how we get this sketch map, because you actually first load the sketch map, have to detect the spatial features and qualify this in the web interface to get this kind of sketch map. You also see the SKMO. The SKMO is the local domain ontology, in this case the Southern Kenyan Maasai ontology, which we need to annotate the rights and the responsibilities. So this local domain ontology is used to annotate the spatial features, which you can see here with the associated rights. So here we have essentially the sketched information with the information on the rights. And when you now compare the base map and the sketched information and align the information in both maps, you can transfer the information about the rights to the spatial features in the base map, and that's what you can see here in this picture. You have the base map and you have the spatial features from the sketch map and the associated rights, and the user could query the rights, the responsibilities within the base map. Now I show you in the SmartSkeMa web interface how adding data works. This is the SmartSkeMa web interface. At the top, you see the different tools. You can load the files, process the images, and so on. And in the main window, we have the place where we can load the sketch map and the base map. First, we need to load the maps, and we start with the sketch map, where we load an image file, so the scanned map. And we do this in the following way. We click on Load Files, Sketch Map, and then we can select one file, which in this case is a PNG file, and load this into the system. So the sketch map is shown on the left side. And now we do the same thing for the base map. We load the base map by clicking on Load Files, Base Map. Then we select the base map, which is in GeoJSON format, which means that all features in the base map are already recognized as features with their boundaries and their corresponding georeferenced coordinates. Now we have loaded the sketch maps, the sketch map and the base map, and you can see both maps side by side. As a further input, we have to load the local domain models. The tool operator can load any kind of local domain model, but of course in this case it's the Southern Kenyan Maasai ontology to annotate this sketch map. So the next step is to process the sketch map and detect all spatial features in the map. This is the object recognition step, which is step D32 in the SmartSkeMa workflow. Now the sketch map is transformed into a vector image, and all spatial features together with the boundaries are stored in the SVG format. So this means we don't have a plain image anymore, but the SmartSkeMa now knows the coordinates of all the features in the sketch map. Object detection is never perfect. It automatically detects quite a large amount of features, but you always need to double check manually if there are some features which were not detected completely, or if there are some features which were not detected at all. To do this, you select the drawing tools in the tool menu, editor, and then you can edit the sketch map via the button Edit SVG. In this case, you can see that the river was not completely detected. There is a piece missing. So we have to complete this geometry by drawing the line and completing the geometry of the river. Once we did this, we can annotate the river by adding a label, a feature ID for the river, and also adding the feature type, which is the type river. Sometimes there are also features that have not been detected at all, such as the borehole here. In this case, we added geometry like this and annotated with a feature name, borehole 1, and the type borehole. If the system detected all other features, we still need to edit these features and add feature names, and in some cases also feature types. If the person who has drawn the sketch map used symbols, they can be automatically detected and the feature type is automatically added. But if there are no symbols or the symbols are not recognized correctly, then we also need to add the feature types. For example, this bomber was automatically detected, and if you click on the bomber, you can add the bomber name, the bomber ID, bomber 1, for example, and confirm that the feature type was detected correctly as a bomber. The next step is the qualification, which is the step 3.3 in the SmartSkeMa workflow. We need to qualify the sketch map and the base map to bring them both on the same qualitative level to compare them. To qualify the sketch map, you can click on Qualify Map and select Qualify Sketch Map. Now our qualifier runs in the background and fetches all detected features and calculates the qualitative relations, such as that the borehole is on the left side of the river, the bomber is inside the marshland, and so on. The system tells us when the qualification process is completed. Depending on the complexity of the sketch map, this may take a while because there are basically hundreds of spatial relations that have to be computed. These relations now are stored in a JSON file. The user usually doesn't look at this JSON file, but I still show you how the file looks like. So here you can see all the different features, the river, the borehole, the bomber, and so on. And in the JSON file, you can also see the spatial relations that were calculated. Here you can see that the borehole is on the left side of the river. Here you can see that the bomber is inside the marshland. Now we do the qualification of the base map in the same way by selecting Qualify Map, Qualify Base Map. And the result of this process is that we have a qualitative description of the spatial configuration of all features in the sketch map and all features in the base map, which then can be compared. This use case was on adding information about rights, restrictions, and responsibilities. So now let's go back to the non-spatial information. For editing the non-spatial information, we can click on the button Edit LADAM, and then we select the spatial feature, and we can edit the non-spatial information like select the ownership, select the party, and select other RRRs, so other rights, responsibilities, and restrictions. We can add this record, and we can do that for a lot of features and then save the records. Once this information is saved and then the data is integrated by align maps, a user, not the tool operator, but another user, could query the base map and finds the same non-spatial information that we added here to the sketch map also in the base map. But this is the next use case. So let's go on with the second use case.
The second use case we'll demonstrate today is that of querying this SmartSkeMa information. So consider again our initial situation. We have some stakeholders. This could be local authorities or NGOs, and the operator here as tool operator or as third-party data user, they want to find out which boreholes exist in this region of interest and what rights are specified on them. And the one thing that the SmartSkeMa will be able to return to them, of course, is the base map with the locations of the boreholes in them. But this is then enriched with data that came from the sketch map and the community mapping, including the information about rights and restrictions and ownership and so on over those boreholes. So essentially, the user simply selects the particular feature for which data was included in the previous step, and SmartSkeMa would return all the information pertaining to that feature. So inside of SmartSkeMa, simply go again to edit non-spatial attributes. You select non-spatial query and click on the feature of interest, and whatever rights and responsibilities on that will be displayed. You can click escape to close that window. In this case, we wanted to know something about the borehole in question here, and we see that the Berisha family has responsibility and has common ownership over this borehole. In the last use case, we considered how to query non-spatial data from SmartSkeMa. In this use case, we demonstrate how to do it for spatial data, so how to perform a more spatial query using SmartSkeMa. For this example, there could be some stakeholders such as local authorities and NGOs again, but also could be the community who are interested in the simple question, whether there are households within a given area where children have to cross dangerous wildlife corridors on their way to school. Now, the data is also similar to the last time. Whatever was already added into SmartSkeMa, so the base map data, as well as whatever was already contributed via sketch maps into SmartSkeMa. When these two pieces of information are brought together, the query can be transformed into a more formal expression that can be evaluated over this data. In this case, we only use the qualitative data, and we formulate the query of crossing a dangerous wildlife corridor by considering the wildlife corridor provided or indicated in the sketch map, and looking at the relations between the school and this wildlife corridor, as well as the bomas, which are the living places or dwellings against the wildlife corridors. So as you can see, what we're looking to find here at the bottom on the right are qualitative relations where the relation of the school and the wildlife corridor differs from the relation of the boma and the wildlife corridor. If this is the case, then to go from the boma to the school, one will necessarily have to cross this wildlife corridor. At the bottom right here, you can see an illustration of what the response of SmartSkeMa should represent. Although we must make it clear that our query is being evaluated in a qualitative sense in a qualitative way and produces a yes or no answer. Okay, so then again, back in SmartSkeMa, we are on the editor panel where we've also embedded our querying functionality, and you simply go to Spatial Query. When you click on Spatial Query, you get a simple query builder window, which is going to open up on your page. And so there, for our example, we want to find out if there's a difference between left-right relations from the school and the bombers against the wildlife corridor. Then we select left-right relation. Here one could select also relative distance or orientation depending on the type of query that is being formulated. And then one has to select the primary object. The primary object is simply the object against which we want to extract all the relations that are available. And then we have the other features, or what you would call secondary features in this case, or secondary objects. But in this case, we want to pick the general feature types for which we should compare. So in order to select multiple feature types, one would have to press Control and select all the features. In this case, I select bomb and school, and I submit the query. Once I submit the query, I get the results, which look like this. There is one school, and it has a relation left against the river. There are 7 bomber features, and they have 3 of them have the relation left, whereas 4 of them have the relation right against the river. So the response to that query, of course, is in the affirmative. There are bombers from which children would have to cross the wildlife corridor. As a matter of fact, that is an elephant corridor in order to get to school. So once you're done, simply press Escape. It will close that window, the query window, and you can go on to proceed to other tasks.